Hello, everybody. So I have a lot to cover. Let's dive right in. We're going to look at an episode of Big Corp Tales, episode 1. We're dealing with unstructured vault secrets. So we have Alice, and Alice is a software developer, and she has written a brand new service, a selfie service. And as you might expect, it takes a picture and it uploads it to Amazon S3. And she's tested it out locally, and it works really, really well. So now it's time to deploy it to Nomad. And to do that, she needs to get some credentials for a new S3 bucket. So it's time to ask the infrastructure team. Now, Bob is on this team, and he is going to work with budgeting and accounting and all these other departments to make sure that this change is allowed. And to get that done, he's obviously going to use Terraform, but he also needs Alice to file a ticket. So Alice sends in her ticket and she says, okay, please, can you create me an S3 bucket for my selfie service and store the credentials in Vault? And here's the path that I'd like them to be stored. So all seems well. Bob creates the bucket and then he adds the credentials into Vault, closes the ticket, check. So Alice, now knowing that the secret is safely in Vault, she writes a Nomad job. Now this isn't a complete Nomad job, but here's the extract that we're looking at. And we can see that we have a template stanza here where Alice is using the path to the secret that she's been given, and she's passing it into the Nomad template to pass it as environment variables to the job. So let's run the job. Oh dear, it's not working. Nomad has reported that there's no secret in that location in Vault. So she gets in touch with Bob, and Bob says, no, you're wrong, it's actually production. It's not prod, it's production. So let's change the key, try again. Well, it's kind of working. So the job's running this time, and 3 out of the 4 keys are working, but one of them is incorrect. So we've obviously referenced the wrong key in the secret. And this makes Alice sad. She's not going to get a promotion this month. So that's what we're going to talk about today. My name is Glynn Forrest, and I'm an independent software consultant. I run a small company called Backbeat Software. You can reach me by email, or I guess over Twitter. I don't tweet very much. I'm going to try and tweet some more. And I have a GitHub profile where I'll be uploading the code to a demo I'll be giving a bit later on. I work with HashiCorp and other configuration management tools in small, medium, and large companies. Some of them you'll definitely have heard of, others you won't have. And you're always welcome to send me an email, and I love talking about HashiCorp. So the agenda today, we're going to talk a bit more about this problem of unstructured secrets. We have 3 ways to fix it that I'm going to talk about, ranging from easy to a bit more involved. And then I'm going to talk about the challenges that I've faced along the way. Then we're going to look at some next steps, things that I would like to do next. And finally, what you can do to help me out and things you might want to try yourself. What I'm going to look at today is mainly HashiCorp vaults, but touching a tiny bit on Nomad. We've really covered all the Nomad concepts we'll be looking at. So Vault is great. Shared secret stores are great if they're managed correctly. So when Big Corp first set up their vaults, they had grand designs for secrets organized by department, by environment, by application. Everything was neatly ordered, perfectly named. But when multiple people got involved, it turns out it looked a little bit more like this. And really, the episode with Alice and Bob is just a symptom of a larger problem. In big companies, if we have anything that's unstructured, that doesn't have a structure forced upon it, it's going to be a little chaotic. It's going to be messy. So what are our goals to try and solve this problem? Well, I'd say, first of all, we want to make sure that Alice knows where the secret in Vault is meant to be. So to begin with, she thought it was secret prod. That's what she asked for in her ticket, but Bob didn't do that. He wrote secret production instead. And we also want to make sure that the structure of the secret is really clear. So when Alice tried her Nomad job the second time, she was looking for access key ID and access key secret, but Bob actually wrote access key ID and secret access key. So we need a way to enforce the structure of our secret as we go. Now, just as a little aside, my personal vendetta against Amazon access keys, the top is how it is done, access key ID and secret access key. But I personally think the bottom would be way better, access key ID and access key secret, but I digress. So fix number one, the easiest way to fix a problem like this is to just document it. Let's just add some conventions to our company's wiki or a documentation page that says, this is how Vault secrets are managed. This is where S3 credentials will go. This is the structure they will have. It's the simplest way to establish some order between departments. We don't need to write any code or really do any process, but of course, documentation has some downsides. It's ignored or not even known about sometimes. People can also make typos or just random human errors. So perhaps Bob meant to type in the credential correctly, but he maybe missed out an underscore or put one S when he wrote access key. So sure, documentation solves the goals we're looking to look at. We have a clear secret location and we have a clear secret structure. But it would be really nice if we could script it somehow, if we could automate it and kind of take the human error element out of the process. So let's try fix number two. Just a really simple script. So let's say that Bob writes a Vault S3 enforcer script. Every time he writes a new S3 credential into Vault, he could run this script, passing in the name of the secret in the command line. And the script's just very basic. This is kind of some pseudo Python code. It would just loop through the different keys that are expected to be there and throw an error if they don't exist. Now this is great, works well for Bob. Alice, however, doesn't really get a chance to see this. She doesn't really know about the secret structure still. So yes, it is scriptable, but it's not the best. And of course, it only supports one type of secret, our Amazon S3 credentials. Let's try one more time. Let's fix this with what I'm going to call static typing. So what do I mean by static typing? Well, a statically typed language, a programming language, is a language where variable types are known at compile time. So before you even run the program, you have a rough idea of the inputs and outputs and the way that data is going to flow through the program. So couldn't we do a statically typed vault? Couldn't we have a vault where the structure and the location of secrets are known before we even pull them out? So before we even run a Nomad job, we could know exactly what the secrets are going to be, the shape of the secrets. So fix 3, we're looking for a generic tool. We're looking for some kind of tool that's going to add static typing to all of our secrets in a key value secret engine. So we have a command that could check that secrets inside of Vault already are matching the structure, but it might be nice for Bob to also have a command to safely write secrets, make sure that new secrets going in are in the correct structure as well. Now, certain secret engines already have this. If you look at, say, the database engine, here's a Postgres example. When we request some credentials from this secret engine, we always get the data in the same structure. We get a username and a password and some lease information. Here's what it looks like in JSON format. This is kind of how the Vault API will return it. You can see that the username and password is nested under a data dictionary there. Now, what about our key value secret engine? Well, it's very similar. Here's a simple secret. We just have a user and a password, both in the CLI format and as JSON. Now, interestingly, because we can put JSON in there, we can use not just strings for our secret values. You can see that we have a Boolean and an integer there, is special and number. Now the CLI on the left-hand side doesn't really show that, but on the right-hand side it does. We can see in the JSON format that we have different types that we need to be able to enforce. And Vault doesn't stop you putting in something a bit more complicated and intricate. This is a contrived example. You wouldn't put a list of users in like this, but we could theoretically have a list of users with this particular data structure. We have access level that has to be an integer and name that is a string. And again, when you see it on the CLI, it's kind of hard to determine what that structure looks like. And in the UI, you'll notice that the JSON editing is the only one allowed when you have secrets in this format. Whereas for a simpler secret, we're able to edit the values using simple text boxes. So what I'm really trying to say is we need a structure for just arbitrary JSON data. Amazon keys at the top, they all need to be strings. And we could go further. We could say that the region must be a valid region. Or below this kind of fictional encryption key we have here, we could say that, well, it has to be a string, but also alphanumeric and 60 characters. We could say that the rounds key has to be an integer in a certain range. So we're looking for a structure of data. Now in software, that's also known as a schema. We're looking for a schema for JSON. Now I know of a project. It's got a good name. It's called JSON Schema, a vocabulary that allows you to annotate and validate JSON documents. So here's an example schema for our AWS access keys. We can see we've got the 4 properties listed here. They all have a type of string. And then region has some extra requirements. It must match this regular expression. Then we have additional properties, false. We can't allow any other keys into the secret. And all 4 of those keys are required. Here's the same for that encryption key, fictional data type we had there, where we have a key and rounds, and then also an optional audit flag as well. So really our fix number 3 needs to be a generic tool that adds schemas. We want to enforce schemas in our secrets. We want a command that reads schemas and secrets and check they match. And we also want to write secrets and check that they match the schema. Now, it would be nice if this tool loaded these schemas from, say, a configuration file, so we could have people write their own schemas. And it would be really nice if someone like Alice, who doesn't have access to Vault, if she could describe what a secret is structured, like what the schema is, without actually connecting to Vault. So I'd like to introduce a tool I've been working on. It's called Vault Helper, very original name. I've been using it for a long time, probably years now, to do just common Vault tasks in the different environments I encounter. Now I have just a few commands from that script that I'd like to share with you today, and these are the schema commands. So we have commands to validate that a secret matches a schema or a whole path of secrets. We have commands to write a secret and commands to describe a secret. So here's a format that I came up with to describe these secret rules. It's basically a JSON schema with some additional information, with a name and a description, as well as a pattern, a regular expression that matches the path that the secret has in the key value engine. So this is the example for an AWS credential. Now, it quickly became apparent to me that writing JSON schemas is good, but it's also a little bit tedious. It takes a while. So I came up with a shorthand. If I've got 100 schemas to write, I want to do it as quickly as possible. So on the left-hand side, we have this little shorthand I came up with that just defines the type, potentially a regular expression or a range, as well as we could prefix it with optional to make the whole thing not required. And you can see what it expands to on the right-hand side. Now, I'm going to give you a quick demo of this Vault Helper script. Let's see if this works. I'll tell you what, I will check that everybody's still here. I'm paranoid that everybody's gone. Yes, we're still live. Fantastic. Okay, so on the left-hand side, I have just a Docker container running Vault in dev mode. I can copy the root token here. Hopefully this is big enough for everybody. Let's walk through the script. So as I said, this Vault helper command has 5 different subcommands. We have 2 to validate, 1 to write a secret, and 2 to describe secret schemas. Here are the rules that we're working with. We've got S3 credentials, where I wrote out the full schema here. We've also got some fictional API credentials, this encryption key that we've looked at already, as well as this complex structure that I showed you earlier. This is how the validate commands look. It's fairly straightforward. You just type a path to the secret you want to validate. Let's look at our S3 creds to start with. Okay, that works fine. Let's check it out in the UI. I need to copy the token again. Okay, so this looks fine, but let's edit the secret. Let's remove region and see what happens. Okay, so it's detected that region is a required property, and that would give a non-zero exit code there. How about this complex secret? Okay, that's valid at the moment. Let's try again. Now you see here, we can't edit with input text boxes. We have to use this JSON editor here. Let's change the data type. And run it again. Oh yeah, it's noticed that. So access level is not an integer, so it doesn't pass either. Now here, we're going to validate a whole path of secrets. We have another fictional service called the back office service that has S3 as well as API and encryption key. Let's add a rogue secret. Bob's gone rogue, and he's added in a secret that doesn't need to be there. Let's see what the validate command does now. Oh, we've got a missing rule. So the secret we just added doesn't match a rule that we defined. So it's classed as a failure. Now I added a flag to ignore that, so we can have the whole thing pass even with a missing secret rule. Let's delete that. And moving on, let's look at staging. Oh dear, it's in a bad way. Starting with API creds, client secret is missing. Sure enough, it's not there. Encryption key, rounds is less than 300. Yes, it's 200. And S3 creds, additional properties are not allowed. Access key secret was unexpected. Kind of sounds like Alice has been here, or maybe me, putting it in the way I would like to see it. So all 3 of these fail to match the schema. And if we like, we can just validate the whole key value engine itself. We can go from secret all the way down and get all the errors or successes. Move on to writing a secret. Let's write some staging S3 credentials now. So I haven't got any further validation other than a string, so I'm just going to write garbage in here. Right, so let's go for a big corp. 1, 2, 3. Now we do have validation here. So if I type in something that is not allowed, it doesn't let you do it. That worked. See if it's gone into Vault. Excellent. And it validates just fine. Now finally, some commands for Alice to run. She doesn't need Vault access to run these. She can describe what S3 credentials would look like. As well as describing what schema a secret in Vault should have. So she's looking up secret prod selfie S3 creds. And oh wait, there's no rule. So her first failure with Nomad would have been caught here. Clicks up production. Okay, she knows what the schema is, so her template in Nomad would be correct the first time. We can also use JSON format if we want to pipe it into something. We can get the same structure that we used in our configuration file as well. All right, finally, here's just a look at what the shorthand looks like. See, it's really quite simple to write. And when it's expanded out, it's a lot more involved. Back to the slides. Now that we've got a script that's working, why not run it in CI? It's something I've been experimented with. You could run this as often as you like to validate that secrets inside of Vault are in the right place and with the right structure. You could validate just one secret or an entire key value engine, and you could even use the ignore missing rule flag to just only validate stuff that you know about. Looking back to our goals then, I think we've achieved them. We have a clear location and structure of our secrets. It's definitely scriptable, and we can write rules to support whatever secret types we need. Some of the challenges I've faced when taking this to organizations, different clients. First of all, the technical side of things. Obviously, you need a good, strong Vault token that has access to a lot. If you're going to try and validate all the secrets in a key value engine, your policy needs to allow for that. It's also pretty tricky to migrate existing secrets that don't fit a schema if they're being used in production. So you have two separate types of S3 creds that are being used by different Nomad jobs, but they're in different structures. That's kind of hard. What I've found is if you make optional properties in the schema, so you could have, say, access key secret and secret access key, both optional, and then slowly but surely you make one required and you get rid of the other one. It's also quite hard to find the usages in Nomad jobs and Terraform and all the other places that we're using Vault secrets. And then, of course, you've got people problems as well. Alice and Bob need to cooperate. You need cooperation between the different departments. I've found it uncovers just really weird usage of key value secret engines. People storing all kinds of junk in there that you didn't realize is quite handy for uncovering all of that. And at the end of the day, it might just be considered too much of a risk. If you're using Vault in a really highly regulated place, you've got another process that's reading secrets from Vault, and it also prints the keys of the secrets and the error messages. So it doesn't ever print the values, or does print the key. It kind of reveals the structure of the secret, which might be considered too sensitive for some places. Things I'd like to do next, I'd like to release this Vault helper script as a standalone tool. Perhaps rewrite it in a different language so it can just be deployed as a single binary on your server. I'd like to support key value engine version 2. So everybody I work with is still on version 1. That would be a great upgrade. And finally, someone talking to me here. No. And finally, if we can do Vault secret support, why not Consul key value support as well? We could enforce the structure of key values in Consul. Why not? I've also noticed that if you're running a Nomad job, it might be nice to know in advance if the Nomad job is correctly referencing secrets with a particular schema. So I'm looking for name suggestions. I'm looking for a good name to use to call this Vault helper script if it supports Consul and Nomad. Finally, what can you do? Check out the demo. I've got a link to it on GitHub. Try writing your own schemas, run it against Vault, and just let me know what you think. Help me come up with a name. So recap, I've gone through the problem of unstructured secrets, 3 ways we can fix it, the challenges, both technical and people, things to try next, and finally what you can do to help me. Back to Big Corp Tales really quickly, episode 2. Alice has got her new service. She wants a production bucket for the selfie service. Bob creates the bucket. He can prove to Alice that he's created the secret correctly because it's validated in CI. There's an output that Alice can look at. So Alice can ship it first time with the correct secret location and schema. and then she can run it. Success. Our selfie service is working and we have our first customer. That's the end of my talk. Thank you very much.